Let us have an example over binary operations. Show that addition, subtraction, and multiplication are binary operations on R, but division is not a binary operation on R. Further, show that division is a binary operation on the set R of non-zero real number. Let us have the solution. Let a binary operation addition be defined from R into R to R. Then, on applying this binary operation, all ordered pairs A, B can be expressed in the form A plus B. Similarly, subtraction and multiplication can also be defined. Let division be the binary operation defined from R into R to R. Then, all the ordered pairs A, B cannot be expressed as A by B, since if B equals 0, then this cannot be defined, hence it is not a binary operation. Let us have another example over binary operations. Show that addition defined from R into R to R and multiplication defined from R into R to R are commutative binary operations, but subtraction defined from R into R to R and division defined from R star into R star to R star are not commutative. Note that R star is the set of all real numbers except 0. Let us have the solution. A plus B equals B plus A. Similarly, A into B equals B into A for every A, B belonging to R. Hence, addition and multiplication are commutative binary operations, whereas A minus B is not equal to B minus A and A divided by B is not equal to B divided by A. Hence, subtraction and division are not commutative binary operations. Let us have another example. Show that a binary operation star defined from R into R to R such that A star B can be written as A plus 2B is not associative. Let us have the solution. The operation star is not associative. On taking 8 and 5 together, 8 star 5 star 3 can be written as 8 plus 10 star 3, which can be written as 8 plus 10 plus 6, which equals 24. While on taking 5 and 3 together, 8 star 5 star 3 can be written as 8 star 5 plus 6, which can be written as 8 star 11, which can be written as 8 plus 22, which equals 30. Let us have another example. Show that 0 is the identity for addition on R and 1 is the identity for multiplication on R, but there is no identity element for the operations subtraction defined from R into R to R and division defined from R star into R star to R star. Let us have the solution. A plus 0 equals 0 plus A, which equals A. Similarly, A into 1 equals A, which equals 1 into A. For every A belonging to R implies that 0 and 1 are identity elements for the operations addition and multiplication, whereas there doesn't exist any identity element for the operations subtraction and division. Let us have another example. Show that minus a is the inverse of a for the addition operation on R, and 1 by a is the inverse of a not equal to 0 for the multiplication operation on R. Let us have the solution. A plus minus a equals 0. Similarly, minus a plus a equals 0. Minus a is the inverse of a for addition. Similarly, for a not equal to 0, a into 1 by a equals 1, which equals 1 by a into a, implies that 1 by a is the inverse of a for multiplication. Click on text for the definition of inverse. Given a binary operation star defined from a into a to a with the identity element e in set A, an element a belongs to set A is said to be invertible with respect to the operation star if there exists an element b in A such that A star b equals E, which equals B star A, and B is called the inverse of A and is denoted by A inverse.